So in this tutorial, we'll be treating the first sub-circuit, the delta sigma modulator. So this is the typical delta sigma modulator. Let me explain how it works. So at the end of the internal operations on the bits, the manipulations on the bits, and it's now time to send it out, maybe to the antenna. So this is where the bits first comes. They come in bytes. See them. So this is where it comes. So when it comes here, it goes through the RAM. It gets stored through the RAM. On the next clock cycle, it comes back here again. This is 8 bits. The RAM is a 9-bit RAM. So what it does is the 9th bit, that is the MSB, the most significant bit, is one that actually goes out. Then from the 8 bit to the LSB comes back and is being summed up with the next input on the next cycle, and then it goes back. So at this point, what you have at this output of this adder is an 8-bit, because the input is an 8-bit, and what is coming here is also an 8-bit, because the 9th bit here has been taken out. The 9th bit has been taken out. This is logic sim. When you see 8, it means it counts from 0 to 8, but I'm actually counting 1 to 9. So that's why I'm saying the 9th bit. But in logic sim, they say 8-bit. So, but I'll still maintain the 9th bit. So the 9th bit is actually what goes out here, leaving in the 9 bits of RAM. If you remove 1, it's remaining 8. So that 8 comes back here and is added to this byte, this 8-bit input here. And this output here is an 8-bit value. So if the adder has an overflow, that is at the end of the addition, there's an overflow. That overflow makes up the 9th bit, and they are summed together using this wire splitter here, and they go out here, and then that overflow is what actually comes here. So in essence, the output here is the overflow of this addition, is what actually comes out here. So this is more like an accumulator. The delta sigma modulator is more like an accumulator. It keeps adding and adding, and you only get a 1 here depending on the value of the input. The higher the value here, the more 1s you get. The lower the value here, the less you get more 0. If this is low, you'll be getting 0, because there won't be an overflow at the end of the addition. It will take longer time to get a 1 at the end of the addition. So if you're having higher value here, that means you'll be getting much overflow at the end of the addition. Between these two, there will be enough overflow, so you'll be getting more 1 here. So that is basically how this delta sigma modulator works. So that means at the end of once the operation in the internal circuit, the control, everything has been done, this is where the bit finally comes out. The transmit bit finally comes out and is being sent out here. From here, this is where the 1s and 0s are sent to your antenna for transmission. It's sent out for transmission. So if maybe let me simulate it a bit. So I want to simulate it, so you see how it works actually. So let me be swap. At this point, you can see everything is 0. So at the output is continually low, 0 0. So if I have like 1 here, it's going to take a longer time to get a 1, get a 1 at this output, and that 1 is coming from the overflow here. So let me be increasing the bits I'm sending. So let's know how fast you'll be getting an overflow. You can see. Now let me make it all 1. You can see they is outputting one more often because the values that I'm sending in is very high, so there is so much overflow. The overflow comes quite very often. So let me reduce the output so you see now it's low. So before it gets a 1, it's going to take time to get a 1. So this is the typical delta sigma modulator. So this is the modulation actually. So let me stop it at this point. So people who have gone through my previous tutorial would know how I got this my RAM. This my 9 bits of RAM. I won't be showing it here. You can check my previous tutorials. It's just 9 flip-flops that are connected in series together to store 9 bits of data. So that's basically how I get this my RAM 9. This is just an adder. This is the input. So it's more like the output, what you want to transmit. So it passes through here, and this is where you get your ones and zeros and all that to be sent out. So you are going to see where it fits, where this delta sigma fits in the original circuit. So okay, this is it. Let me reduce the size actually so you can see where it fits in. So this is it here. You can see that the reset and the clock, usually the whole circuit will always have a common reset and a common clock, so that's normal. Then this is the output here. So this output goes to whatever is doing your final transmission. Then this in is the output from your modulator, from your transmission modulator. Let me highlight it so you can see what is written there. See where it's coming from, mode out. So at the end of your modulation, this is where you send it out to be transmitted to here. So that is it for this sub-circuit delta sigma modulator. In another tutorial, I'll be talking about this ADC. Thanks. Subscribe to my channel, please.